So hi everyone, I am Kendall Moore, and this talk is going to be a decade of compliance with Puppet. And so throughout this talk, there's going to be a couple of themes, and they're sort of going to be paralleled. They are Puppet, which is the language and company that you all know, and SIMP, which is a framework that you're going to learn more about, and my experience with those. I've worked with Puppet and with SIMP for about 10 years now. I've been a certified Puppet consultant going on 5. I work for a small company called OnyxPoint. We are partners with Puppet, and we are a development slash contracting slash services company. My title does say director, but probably most people in the community would know me as a Puppet consultant or someone who has been a Puppet developer for many, many years. And lastly, I consider myself a reluctant compliance expert. And if you're wondering why I say reluctant, to everyone at Puppet and all the other folks listening in, if you're just getting into compliance now, if you notice the need for a haircut and the unkempt beard, that is not because of coronavirus. That is a look into your future, which is compliance. Okay, so I said I was going to talk about 2 things. Those things are SIMP and Puppet. I'm going to start a little bit with SIMP, what it is, and then I'm going to talk about how it's evolved with Puppet over the years. So to get started, SIMP at its core is really just an OS automation framework. The goal is compliance, but broadly speaking, it's also meant to be just overall system management. The idea is to harden and persist system configuration, and it's supposed to minimize drift over time. So SIMP, really, if you remember nothing else about this slide or some of the other things from the talk, the main takeaway is that it is an OS framework which is meant to manage compliance at the operating system level. It does so using a collection of Puppet modules. Some are developed by OnyxPoint directly. Some of those are community modules from the Forge. And some general things that you might recognize having been in compliance are something like risk management framework. Probably a lot of you have heard of NIST as the National Institute for Standards and Technology. And NIST comes up with a lot of policies that other compliance standards are derived from. We'll get into some of those in a minute here. But we also have the ability to do custom compliance policies. Again, more on that to follow up. A little background on SIMP is that SIMP is a little more than 10 years old. SIMP started off as a bit of a research project. So before 2009, the initial developer of SIMP, his name is Trevor, he's probably hanging out in Slack right now. He was playing around with Puppet, and his goal was basically to stop having to try and harden operating systems with one-time Perl scripts. Oftentimes those Perl scripts wouldn't work, or even if they did, no one really knew what they were doing, and if the person who wrote them ever left, they were sort of hosed. That probably sounds familiar to people. Replace Perl with Bash or whatever other scripting language people were using. So the first release of SIMP, which was in 2009, was centered around Puppet version 0.24. So I don't remember the exact release date of Puppet, but I do know that it's been a very, very long time. So we've had the opportunity to sort of see Puppet grow from its inception. An example of that was the creator. I mentioned his name, Trevor. He actually attended Luke's very first Puppet training, one that I believe, if I remember the stories correctly, he accidentally went through all of the content in the first day instead of it lasting for the whole training session. So Luke had to stay up all night building content for the remaining days. And the last thing that you should know about SIMP is that it was open sourced by the NSA in 2015. And yes, I do mean that NSA, not as interesting as it sounds. So some examples, this is not an exhaustive list, but to get you an idea of the policies that SIMP aims to manage for you. Some NIST ones, CIS, which was nicely timed with Yvonne's keynote. I actually did not know that we would be talking about CIS and compliance in the keynote, but a little serendipity there. I'm glad that I can be talking about it too. PCI is a popular one, HIPAA, SOX. I'm guessing that probably most of you have run into something from one of these in the past. Okay, so what does any of this have to do with Puppet, right? Well, let's talk a little bit about the history of Puppet. There are things that we take for granted now that just weren't always the case. And a great example of those would be Puppet modules. So I mentioned that the first release of SIMP came around Puppet 0.24. Well, that predates the existence of Puppet modules, believe it or not. Someone can fact check me on this, but I think Puppet modules were introduced maybe in Puppet 0.26, so many, many years ago. So what did that look like? What was even Puppet or compliance before there were Puppet modules? Well, some of you might remember the import statement and specifically node definitions. So what people would do is import a collection or a glob of node definitions using this import statement and a star. And oftentimes you'd have something just called nodes.pp or base.pp, and that would basically define what your OS baseline looked like for all of your infrastructure. So it's important to note that I keep saying OS because back in the day, Puppet was really targeted at the operating system and component level. There were people that were doing some things with applications, but that really didn't become a mainstay until a bit later on. So way back when, we had this. We had these node definitions where you could say something. You wouldn't typically say node hostname unless it was really customized, because even back then we didn't want snowflake nodes if we could avoid them. So basically it was, how do I define this? Well, here's what an SSH node looks like. Here's how I configure SSH, and here's how I configure NTP, things like that. So it's kind of spread out in the same way a Puppet module might be, just without the concept of modules. Okay, so when Puppet modules were introduced, what did that do for us? Well, it sort of allowed us to write more atomic code, which is important, especially when it comes to testing. Prior to Puppet modules, you just sort of had these globs and chained imports and chained inheritance and other things, and it was a mess, right? So testing really wasn't the nice RSpec or Beaker or Litmus testing that you see now. It was basically just, here's a bunch of node definitions, put this on a node that we're relatively certain won't explode and see what happens, right? And that really was what a lot of the experience for myself and some of our downstream customers back then was like. You know, it was all about being as careful as possible. So as soon as we got Puppet modules and we could sort of test things independently, we could separate code out by operating system component, it really set SIMP up to sort of hit the ground running. I believe after 0.2.4 or 0.24, the next release of SIMP was based on Puppet 0.27, and the main focus of that release of SIMP was to break out all import statements and make component level modules. This sort of predates the idea of roles and profiles, if any of you are familiar with those terms and thinking about those. We'll get to those a little bit later, but this is really, really meant at the OS component layer. And eventually on, what we got to was this params pattern where you could sort of set nice OS defaults using big case statements inside of your modules. And that was a really great start. And so I'm sure most of you are familiar with the Forge, but I mentioned there being a nice centralized collection on the last slide. I'm specifically referring to the Puppet Forge. The Puppet Forge, when it was first introduced, was a bit of the Wild West. Much like now, anyone could upload their modules, but the quality scores and the community scores, those didn't exist right away. And when they were introduced, you know, I would say that it was a bit of a learning curve to even understand how you could trust certain modules. There have been some modules, some authors that have had things pretty much since the beginning of time. I'm thinking like SAS, for example. A lot of people use his sudo or SSH module, or Garrett Honeycutt has a lot of modules that have been around. So there are some that were you know, focal points that everyone used, but then there was lots of other stuff. You're like, well, if I can manage NTP, I want to manage this other thing, right? Well, maybe. That's all I'll say about the early Forge. It's much, much better now. Okay, so what was wrong with modules? Well, the initial design was actually really great. So I will say the idea was perfect. I'm glad that they were created, right? They're still in Puppet now because they're so important. But they weren't perfect, right? So we fell short in a little bit, in a few different ways. And one of them has to do with data. So in most applications, in most programming languages, there is this concept of data separation where your data layer does not exist within the code. Puppet didn't really have that at first. So, you know, how did you override things? How did you change things? You know, okay, I'm using this early version of SIMP and it does this, it helps me meet NIST 853 and that's great, but what if I care about HIPAA, right? How do I actually override some of these settings? Or better yet, you know, you've done something like changed SSH to no longer allow root login, but I have to support this application, right? And this application was built 10 years ago and it requires root login and we all hate it, but it's there, right? I'm sure most of you have had this conversation. So what do? Well, the answer was you write Puppet code, right? You either write a profile or you write your own module if you don't like the one that's out there. And so the response that we would see is, are you telling me that I actually have to write real code if all I want to do is change one value in a config file? And pretty quickly, everyone realized, okay, yeah, that's a problem. So what do we do? And the answer is separate out the data. So before there was Hiera, there was Extdata. And I don't know how many of you used Extdata, but it was similar to what we think of as Hiera now, except that it was a CSV-based data store layer. It did have a function called ext lookup, which could read in values from your external data store and be included into the catalog at compile time. It was independent of Puppet modules, which was great, which means we could write more robust tests even yet that could split out data among different nodes or among different groups and sort of change default behavior. So this is awesome, right? Yeah, this is a great step in the right way. But were there problems? Yes. So first and foremost, CSV, not a great data format for complex data structures. I'm very specifically thinking of hashes. I see more and more in modern day Puppet modules where Forge module writers will just do something like, here's some default values that I think you'll probably care about. But if I didn't cover everything, here's this generic options hash, and then you can just, splat this entire thing into a config file. Imagine writing one of those in CSV. That's all I have to say about that. So great first step, but even pretty early on into CSV, I think RI Pioneer maybe wrote a blog post about people wanting YAML backends or simpler solutions, and that is exactly what we got. We got Hiera. I'm going to call this Hiera old. So you'll see two slides, one that says Hiera old and one that says Hiera new. Please note that for Hiera old, I am talking about Hiera v1 through 3. And then newer than that will be Hiera new. See that in a second. So like Extdata, this is another external data source. It is in YAML or JSON. I would say clear and away the most popular backend is YAML, if for no other reason than it supports comments. And YAML seems to just broadly be more popular than JSON these days. It also added this really nice feature where we could do node classification through Hiera. So we could use this Hiera include function, and most commonly people would have an array that they called classes, and then you could sort of merge these classes from your different Hiera backends, and boom, there you go. This is what your catalog is going to look like. So that was great. It gave us this ability, like we were doing with code, to use Git-based workflows where we could, source control and code review things that would impact classification, as opposed to ENCs, which can be tough. And it was great for people that were not Puppet Enterprise users because it gave them the ability to do node classification without having to write their own custom ENC. The data format much better matched Puppet types. So Hiera does predate Puppet types, but in the introduction of Puppet 4, it introduced strong typing for class parameters. And the Hiera data format allows you to match those with proper Booleans or strings or hashes. I know that when I first started doing Puppet consulting 5 years ago, one of the most popular things that I would do is I would go to customer sites and I would do a Puppet 3 to 4 upgrade. And a lot of that involved Hiera and modifying Hiera to match the types of class params. And in fact, I want to give a shout out to Ranjit here, who right when I was starting consulting actually came to the OnyxPoint office and gave us a talk on the catalog preview and upgrading from Puppet to 3 to 4 in general. Ranjit, that helped me for at least 6 engagements in a row right after that. So thank you very much for that. It also introduced some other Hiera functions. I'm thinking Hiera hash, Hiera array, and just Hiera lookup, which is just called Hiera. And those were all great. So now we have all of these wonderful ways where we can transmogrify data, manipulate it, etc. And we also got custom Hiera backends. And so some of those could be REST APIs. It could just be simple HTTP connections. And there were even some out there that would do an ext style lookup. So you could use your old ext data while you were still migrating. So compare this to the old ext config file. It actually looks pretty similar. You define your backend as YAML or JSON. In this case, this would be logging to the PE console, and then you sort of set up your hierarchy. So this is different by maybe 1 or 2 things from Extdata, so really built as a stand-in replacement, just with a little more functionality and a little easier to use. Okay, so did we do it? Did we finally get this perfect data layer? No, but much closer, right? People are happy with this. One of the big problems is that with Hiera v3 even, you didn't really seamlessly integrate with environments. So I'm going to take a step back. And if you note here that there is a dynamic environment variable, that was sort of a problem, right? You could use an environment fact to determine what environment you were in, but you ended up with a lot of duplication throughout your hierarchies. You would have something like, OS level or node group level or app tier or data center, things like that that are pretty common in hierarchies, but you'd have to duplicate them. So you'd have this dynamic environment variable before your data center, your geographical location, et cetera, because these things were different in different environments, or at least they could be. Right, so that's one example. Another issue was that default data was still typically living within the Puppet code. I previously mentioned that params.pp pattern. Well, it was pretty well established by the point that Hiera was out. So we still had this define OS defaults. You'd have something like case Red Hat, case Windows, case Solaris, and inside of there, you'd set your different NTP data, and then you'd repeat this for every single component module you had. And it was okay. Inheritance in Puppet is a little wonky. You get used to it, but it doesn't work the way you would expect inheritance to work in, say, like an object-oriented language. So it's a little bit confusing for users. And also, there definitely was some room to improve when it came with data manipulation. So you could create a hash or an array, but really it didn't always do what you wanted. So you found yourself writing custom Ruby functions to try and do what you want, and it was okay, but definitely could be better. So what next? Next, we get Hiera new. And so very specifically, what I'm referring to with Hiera new is Puppet Lookup. Puppet Lookup is sometimes known as Hiera v5. Some really great features of this. One, it exists at the environment layer, which means that every instance of your environment level Hiera is isolated to that environment. This means that we could completely do away with the global hierarchy. And in fact, for most customers, what I'll do is have them create an empty hiera.yaml at the global layer just to make sure that there's nothing in it. You don't accidentally want to override anything. It also added module data layer. This is great. I'm sure any of my coworkers who are in Slack right now can tell you that ever since Puppet Lookup was introduced, I have pushed and pushed for having OS defaults and default data inside of the module. And that is a good thing. And it also helped out in a couple other ways. We'll get to those in the next couple of slides. So we also added some APIs for custom backends. We had data hash, lookup key, and data dig. Data dig is basically connect to a database. Lookup key is like your custom lookups that you do. And truthfully, I forget what data hash is, but I could look at the docs. But anyway, it added a bunch of APIs for custom backends, which meant custom Hiera backends were much, much easier. We also added lookup options and some better data manipulation strategies. So lookup replaced the Hiera functions, Hiera underscore array, Hiera underscore hash. And lookup allows you to actually specify the object type that you'll get in return. So that could be an array, like if you were doing node classification with lookup, you could get hashes, which you could do shallow or deep merging on. You could do a lot of stuff. And you could actually set the lookup options for an individual lookup call at any point in your hierarchy. So that means if you want to have something custom about the way module defaults are looked up for your NTP component module, you can do that. You don't have to require the user to do anything about that. And that was great. We also added some command line utilities. So we can use Puppet Lookup on the command line, and we can sort of get an idea before we ever run Puppet on a node. We can get an idea from the Puppet server what exactly would be in our catalog. We can check any key value pairs we want. And another nice feature, this didn't come with the introduction of Puppet Lookup, but it is true. You can actually use your data for Puppet Lookup in Bolt. And that is one of the things in my mind that makes Bolt so powerful, is that you have this really great task engine and you have years and years of data that you've been building for your Puppet infrastructure. In the case of SIMP, this was 7 or 8 years in the making at this point. So we had all this data that we could just now start applying with Bolt as a one-time operation. I'm a big fan of that. Okay, so, aren't we talking about compliance? Well, yes. So some thoughts on that. Talking about Puppet is probably more fun than talking about compliance, unless you're one of 3 people in the world that really loves compliance and aren't reluctant like me. And so what does Lookup have to do with it at all, right? And SIMP is 7 years old. And didn't we say we were doing compliance for more than 10 years? Yes, I did say all of that. So how does any of this help? And the answer is SIMP Compliance Engine. So SIMP Compliance Engine started off as a reporting tool. Really quick piece of history about SIMP Compliance Engine. It was actually generated at one of the days of PuppetConf in 2015. It was part of the code hackathon where I believe my boss put together something and thought, I think people would like this. And so that initial start at PuppetConf was for a reporting tool. And that reporting tool would basically use a custom markup language, and it would generate a compliance report based on how compliant your compiled Puppet catalog was. That was a lot to say, so hopefully I didn't confuse anyone, but stay tuned. We'll try and break it down a little more. After the reporting tool was generated, we created a custom Hiera backend, which was specifically used for enforcing change at the OS layer. A policy translation strategy. I completely made up those words in that order, so if you've never heard that before, that is why. What I am defining a policy translation strategy as is a way to take human written policy that sometimes is laws passed by Congress, sometimes it's rules implemented by an organization like CIS, sometimes it's standards from NIST, right? So it's all of these things that have disparate sources, and you sort of have to combine them and then figure out how they actually apply technically to an operating system. That's what Compliance Engine let us do, is it let us define a data format to say, this is what compliance looks like at the OS level. Beyond a technical tool with a repo that you can find on GitHub, Compliance Engine for us at OnyxPoint was also a new approach to module and data design in general. One of the things that we did was start putting compliance data in our component modules and also add the ability to add that at the environment layer, again, just paralleling exactly what Hiera v5 or Puppet Lookup would let you do. And it also sort of helped us redesign SIMP in a way that would be more flexible for our users. Remember, I talked about SIMP being created at a time where there weren't even Puppet modules, right? So SIMP has had to evolve with Puppet over this 10-year period where when there are new tools like modules or Extdata or Hiera or Lookup, we're sort of always re-architecting SIMP to try and use those new paradigms in a way that'll make life easier for users. Because I think at the end of the day, what we have to remember is that when Puppet makes changes, like including Puppet Lookup, they're doing so for ease of use for the users. So we're trying to tack onto that as much as we absolutely can. So talk a little bit about the reporting. I said that a compliance report using Compliance Engine is generated at catalog compile time. That is done with a bit of magic Ruby code that runs inside of the Puppet server process. And what it does is it takes a catalog after it's been compiled by Puppet server. It reads the profiles for compliance, such as HIPAA or SOX or CIS or whatever that we have written in our markup language, and it compares that catalog to that profile, and it will generate a report and tell you how compliant you are. And so it's important to note that this report is, again, based off of a Puppet catalog on the Puppet server. It is different than a scan, like, for example, Nessus or something from Rapid7, where you're actually scanning things on the OS. If you're wondering why we do this, anyone who's ever worked in and around government has probably heard the term defense in depth. This is part of our defense in depth strategy where we say you want to make sure that things are compliant every single step of the way rather than trying to figure out if something's compliant once it's already made it to the OS. And so by generating these reports about a Puppet catalog, it sort of lets you know before you ever deploy it or before you ever run Puppet, do I actually expect this node to come out compliant on the other side? And so this can be used in conjunction with tools like Octo Catalog Diff, or I believe Puppet actually has a new tool built into Puppet Enterprise. I was actually talking with Gene about this the other day, where it'll sort of give you it'll precompile a catalog and it'll tell you the changes that would have been affected on a system. That was not a tool I had seen before, but I'm excited to work with Gene and the other folks at Puppet to see if maybe we can combine forces here in a few ways, see if we can, maybe say, well, this is what we do for compliance reporting and here's all the stuff we have. So I'm definitely excited about Puppet's future with compliance and sort of joining forces on some of this stuff. Hopefully your beard doesn't start to grow gray like mine does in a hurry because of all of it. Okay, so in addition to to just like the standard compliance reports that you might get from a scanner. We have the ability to configure it a bit, and we can add custom checks. Custom checks can either be added through Hiera if you use our markup language, or there's a defined type within our compliance engine module, and that defined type will allow you to create policy checks on the spot as well. And here's a couple examples of the kinds of reports we can generate with a full report, which is everything. Non-compliant, which just says, show me the things that didn't pass. Compliant just says, show me all the things that did, or you can show just the custom entries. Sorry. And here is a quick example. So this right here is just a simple JSON report that was generated. This isn't really the sort of thing you hand off to your manager. This is more of the thing that you hand off to Splunk or an Elastic Stack, and then your security team build some metrics and monitoring around this where they can kind of, it's just simple JSON, so it's pretty easy to parse, but basically for each individual check, you might have something like audit chmod. For those of you that are not Linux users, this basically says audit anytime the permissions, anytime the owner and group of any file or directory was changed. In this report, we're saying that if you were to be compliant, then the value should be true for this Puppet class parameter, but in your Puppet catalog, it was actually set to false. And this right here is the identifier from NIST 853 that you would be failing if you needed to go back and reference it later. And so a report will probably look like this, many or hopefully not any findings, but if there were, it'd be findings like this. It also shows you, if it's not as simple as a class parameter, it shows you if an entire module or a defined type for configuring dynamic things. It will show you if those are missing from your catalog as well. Okay, so the custom Hiera backend for enforcement. The SIMP compliance engine uses the Hiera Lookup key backend, and specifically that is called compliance markup enforcement. So what we recommend people do is add that to the very bottom of the hierarchy in Hiera.yaml for an environment. And then if so, it sort of allows them to have a baseline that is compliant with the policy they're looking for. This tool, this compliance markup enforcement, it reads data from a couple of different places. It looks for SIMP compliance profiles, that directory path, and it looks inside of all of the Puppet modules, and it also looks at the top level of the environment. And what it does is globs all of the valid Hiera files from that directory and then starts applying them to the catalog as necessary. Sorry about that. And what it allows you to do is sort of isolate your compliance profiles from all of the rest of your data. So if you were to look at some of the SIMP Puppet modules, maybe auditd, SSH, some of the basic ones like that on GitHub, you would see the SIMP compliance profiles, and you might also see a data directory. And that's because compliance data is generally different than the data you get from the OS. And so the reason we have that split up is because we definitely want to provide people with default data that sort of gets their component working, right? Like no one would want to run Puppet and have SSH left in a broken state or in a state that maybe is too locked down for what they wanted. So you don't actually have to do the enforcement to get the reporting that we talked about on the last slide. You just leave this out of your hierarchy, and then you can just turn on reporting and skip the enforcement for now until you're ready. And so by separating these out, it allows users to like easily toggle this or ease into it themselves in their brownfield environments. Okay, so a quick example. This is just what a HIPAA profile might look like. So this is the SIMP compliance engine markup format. It's always just going to be YAML, just defined in a very specific way. So here we define what our profile looks like, called HIPAA. And then HIPAA is really just a bunch of controls. And so I mentioned before that a lot of policies are derived from something in NIST. HIPAA is one of those examples. So here's a quick subset of some of the things that would be included in a HIPAA profile. If all of these just look like letters and numbers, that's fine. Don't worry about that. Just know that this might, for example, say audit chmod on Linux systems. This might say let your password be at least 10 characters, those sorts of things. That's what it boils down to. And the reason that we have these as key value pairs that you can toggle is that it allows you to either add these things one at a time, or you could also import an entire other policy. Like let's say we could say HIPAA imports all of the NIST 853 controls. And then for the individual ones we don't want, we could toggle them to false like this. Okay, so what does a policy check look like? It looks like this. This is actually valid Hiera data. And so what this would do on the back end is it would take the SSH permit root login setting and it would set the value to false. So if we look under this settings hash, there are two things, the parameter, which is the Puppet class parameter, and the value, which is false. The type here is just to be as explicit as possible. There's also some metadata to tell you which controls they are. A control is sort of like a checklist, and which identifiers, which is sort of like the index of a book, right? This just references the actual policy. Okay, so that was a lot. That was pretty heavy, right? This seems complicated. First thought, this is not complicated if you've been in compliance for a while and you've ever had to look at an XCCDF checklist. Oh God, those are awful. Okay, but admittedly, yeah, this stuff is a little bit complicated. So why did we do it and why am I showing you, right? Well, the good news is that we did it so that we could do all of it, right? We have mapped as many regulations and policies as we can think of. We have done so in as complete of a way as possible. So we've implemented the checklist for all of those major policies. And we did this because we don't want other people to suffer the way that we have suffered for these 10 years, right? We want these to be accessible to people. The other news, or the other good news about this is that if you just add the enforcement layer to the bottom of your hierarchy, you can override anything with simple key value pairs, right? So if I go back a slide to here, I told you that all of this is what you have to do just to turn off permit root login, or I guess to enable permit root login within SIMP, right? Well, because we've done this for you and because we've defined this as the compliance standard, all that you have to do to change this yourself on your node is just set this key and this value to true inside of your hierarchy at any layer, and then it just works the way that Hiera works out of the box, and you've changed that setting. It'll show up in reporting, and you'll know that there is that it's not compliant anymore, but there's probably a good reason for it. But it's just as simple as a key value pair. You don't have to be the one who's writing code or data that looks like this. Okay. And so I just want to give you all a quick little preview of what the SIMP console looks like. This is an enterprise value add to SIMP. Compliance Engine is an open source tool. We do have some enterprise features that add onto it and build from it. If you were to log in, you would see something like this, where you sort of have your data centers or other clusters defined, and you could dig through them. Digging through, you might see the results of a scan. So I want to point out that this is not from the SIMP Compliance Engine report. This is from, for example, it could be from a CIS scan. I think this is actually from an OpenSCAP scan, but we support that, CIS and some others. And so what we do is, based on those scan results, we map those to the checks. Go back a couple slides to here. We map the things from scanners like the CIS scanner or OpenSCAP. We take the findings from them, and we figure out how you can actually remediate them with Puppet. And so if you were to click on one of these, this is a screenshot, not an actual demo, but if I were to click on one of these, it would pop out this drawer. It would give you some information about the check. It would tell you about the description and the control. And this right here is actually valid Hiera data that you can copy paste into your hierarchy to automatically remediate those findings as they come up. And so that's really the main reason that we wanted to build SIMP Compliance Engine long term, right? One, we wanted it to be useful to people, even open source people, right? We don't want it to be a paid only feature, but we knew that we wanted to do something beyond just give information to people about what they're failing. We wanted to be able to help them actually get beyond that. So we have this Hiera data that you can copy paste. I mentioned before that your Hiera data can work within Bolt. So if you had a Bolt set up, you could create a plan or something, or you could just run Bolt apply and add this to your Hiera and then see what those changes were in a one-off setting rather than apply them all at once. Okay, and this right here is just, again, a more simplified screenshot of what you saw on the previous slide. So this is really drilling down into a finding from a scan and saying, here's the information, here's the check or the control that you failed, and here's the Hiera data that you could add that would remediate it. And so that's really all that I had. I hope you guys have come up with at least a couple of questions. I realize now after the fact that I broke one of the important rules for being a speaker, and I did not put my Slack handle on a slide. So I will tell you all, if you see my name here in the bottom right corner, I am at Kendall in the Puppet Slack. So if you have questions for me now or in the future or whenever, feel free to ask them. And just some quick general information if you want to come ask us more about SIMP. You can either reach out to me personally or join us on Slack or shoot us an email or anything else. And I hope you all enjoyed.
So enjoyed, they did. There was quite an active conversation in Slack during your entire talk. You sparked a lot of ideas and a lot of conversation and a lot of thought. Not a lot of questions, but we do have one. You did have your name pinged a couple of times, so people have seen your Slack handle show up in channel.
Okay,
so they'll
good
see
deal.
it directly. Michael would like to know if the SIMP console can use PuppetDB facts in their hierarchy, or whether you can use data from SIMP the other direction.
The answer is no. The longer answer is that is an absolute must-have feature. You are not the first person to ask, and it is on the roadmap. So stay tuned. I assume that you're meaning specifically for these folders. Like, could I separate these folders and where nodes show up in an organizational way based on some custom fact or some other data? And again, if that is the question, the answer is not yet, but coming soon.